So this is just a quick review of solving equations in quadratic form. So just the way that these work. So I show a few examples, but if you need like a full lesson, I have longer lesson videos where I really break this down. So just look in the description for that. So what we're going to cover in this video is, okay, so how do I explain this? So this is your standard quadratic equation. So here's our quadratic variable, right? And we would factor this. So the idea of equations in quadratic form, they are things that are not actually quadratic, but they kind of act like it. So I want you to pay attention to the exponents. These are all like the same coefficients. So here, if I were to just multiply the exponents here by 2, I would get x to the 4th, right? And then 3x squared, because this x has this invisible exponent of -1. So we've got this exponent, and then if I were to multiply it by 2, I would get to this. So notice that that pattern kind of continues with these other like equations. So I've got x to the -1/3 and x to the -2/3. So it's the same idea, right? If I multiply this exponent by 2, I would get this. And I could also basically manipulate this equation. I could divide all of the exponents here by -3 to get this equation. So it's like this specific pattern that you're looking for where one exponent is double the smaller exponent. So the same thing works here too, right? So if I were to take these exponents and just divide them by 5, I would get x to the 2/5 plus 3x to the 1/5 plus 2. So when this happens, this is what's known as the equation being in quadratic form. And so you can do something to kind of still leverage quadratic form. So I think the easiest way to handle something like this, so I've got x to the 4th minus 10x squared plus 9 equals 0. The way I like to teach this is I like to use substitution. So we create this new variable, let's call it u, and we set it equal to the lowest of the two exponents, okay? And then we ask the question, what would happen if I were to square u? So if I were to square u, that would be the same as me squaring x squared. So I've got x squared. How do I simplify these exponents? This would become what? X squared squared is x to the 4th. So I think it's really important to actually force yourself to do this little middle step here, because this is a good way to convince your brain that you can actually do this, because sometimes you could look at some of these equations and they might not work out like this. Okay, so now where I had x squared, I'm going to replace it with u. Where I have where I have x to the 4th, I'm going to replace it with u squared. You got it? So now, how can I rewrite this? U squared minus 10u plus 9 equals 0. And so the reason that we do that is I can solve this quadratic no problem, right? So if I just go ahead and solve, I can actually factor this. So this becomes u minus 9, u minus 1, and then as I go along, oh, I'm so happy, this is so easy. I can just solve it like a normal quadratic. That's kind of why we like that. And now it's like, well, what do we do now? Because we weren't solving for u, we were solving for x. So this is where, so I want to make this nice and clear, this substitution, this u now needs to become an x squared. So I replace my u with x squared, and now you just have to kind of put your thinking cap on for a moment and think about, how do I realistically solve this? So I would take the square root of each side, but what happens when you take the square root of each side? When you take the square root of each side, you're using the square root property. So remember, this would become x equals plus or minus the square root of 9. So you always have plus or minus with that square root, and the same thing can be said here. This will be plus or minus the square root of 1. So I get the answers plus or minus 3 and plus or minus 1. Now, is this how you always solve this? No, it actually depends on what your u is. And so that's what we're going to kind of investigate, because that's what gets kind of tricky for people. All right, so let's look at another example. And this one looks, I know, really wacky, because now I've got x plus 1 to the 2/5, x plus 1 to the 1/5. So the thing that matters here is that I've got 1/5 and 2/5. I can multiply this exponent by 2 to get to the other one, and these are both x plus 1. All right, so I can still use my u substitution here. You set u always equal to the lowest exponent. And in this case, instead of this just being x, this is going to be x plus 1 to the 1/5. And so then if I do my u squared, if I want to figure out what that is, so I know that to square this, all I have to do is multiply this exponent by 2, and what would that lead me to? The thing that's important here is that you don't just take this other exponent. You want to take a moment to logically think through, if I create this as my u, do I logically actually arrive at this other exponent? So if I multiply this exponent by 2, that would give me x plus 1 to the 2/5. So yeah, we are good here, right? So this just so happened to work out this way. So it's kind of important that you take that moment to like logic this. All right, so now where I had this x plus 1 to the 1/5, I'm going to replace it with u. And then where I have this x plus 1 to the 2/5, I'm going to replace it with u squared. So look at how much easier this problem, like this crazy looking problem, becomes. This becomes u squared minus 3u plus 2 equals 0. All right, well, we can solve that bada bing, bada boom. So this becomes u minus 2, u minus 1 equals 0. Cool, I got u equals 2 and u equals 1. Oh wait, but we're not done, right? Okay, so now what was the next thing that you need to do? The next thing that you need to do, right, is you go back to the original u and make this replacement. So what I suggest that you do here is, so if you've been watching my series of review videos, I recommend that you pause the video here and you try to finish this on your own. And if you get stuck, that's totally fine, but you'll get more out of this video if you spend a moment thinking about this than if you just watch the solution. So I suggest you hit play when you're ready. So this becomes x plus 1 to the 1/5 equals 2, and x plus 1 to the 1/5 equals 1. And now, like I said, you've got to put your thinking cap on, because anything goes to solve this last part. So you have to just think of all the math you know. So if I want to get rid of this rational exponent, what I'm going to want to do is I'm going to want to take both sides to the 5th. And I've talked about that in another review video, so I will drop a link to that in the description. So when I do that, this becomes x plus 1. So what is 2 to the 5th? So let's see, we've got, let's see, 4, 8, 16, 32. Okay, 32. And then x plus 1 equals just 1. Okay, and so now if I finish solving this, so if I subtract 1 from each side, I get the solutions x equals 31 or x equals 0. And so now I've actually solved it. And as you can see, so using that substitution technique was really useful, because this looked really wacky, right? It was a wacky problem, but not so wacky if we use substitution. So substitution is our friend. All right, so I have one more here. I mean, you know what I'm going to tell you. I think you should try this one totally on your own. The worst thing that happens is that you get it wrong, and when you get things wrong and then you watch the correct solution, that's when learning actually happens. So pause here, give it a try, hit play when you're ready. Okay, so my u in this case is going to be x to the negative 1/3, and I can see if I were to multiply this exponent by 2, that will give me u squared, and that brings me to x to the negative 2/3. So again, I did not just blindly grab this, right? I logicked my way through to prove to myself that this is the correct exponent. All right, cool. So now I'm going to make these substitutions. This becomes x squared, u squared minus u minus 6 equals 0. And then this becomes u minus 3, u plus 2. Oh, it's just so beautiful. It's so much easier to solve. All right, so now I'm done, right? No, I'm just kidding. I'm not done. All right, so now I have to go back and replace my u with this x to the 1/3. And again, now we got to put our thinking cap on. I don't even know. What does a thinking cap look like? Dumb thoughts I have while I make videos. Thank you. All right, so now, yeah, what do I do? All right, so I need to get rid of the exponent, and so I can still use this principle, right, of kind of multiplying by the reciprocal, but this is also negative. So I want to take each side now to the negative third exponent. Because when I do that, then that's going to leave me with just plain old x, right? So let's see, all of this to the negative third. So I've got now, let's think through this. X equals 3 to the negative third. What is 3 to the negative third? Well, negative exponent means that I rewrite this as 1 over 3 to the third. So I get x equals 1 over 27. And x equals negative 2 to the negative third. That means that I'm going to get 1 over negative 2 to the third. So I get x equals 1 over negative 8. Cool. All right. That was fun, right? You'd probably like show somebody how to do that at a party, right? I probably would. All right. So if this went too fast for you, I suggest that you look in the description, and I have some links to some other videos that go just at a slower pace. I make this series because I'm trying to help some my pre-calc students review. So, you know, we've only got so much time for that, but if you feel like you need more, don't worry. I have talked about this in way more detail in other videos, so I've got you. Look in the description. Otherwise, that brings us to the end of this video. If it was helpful, consider leaving it a like. If you got any questions, you can always leave me a comment. And otherwise, thanks for watching, guys. I will catch you in a different video.